नमस्ते। पृथ्वी पर मानव जीवन की उत्पत्ति एक बहुत ही रोमांचक विषय है. The origin of human life on Earth is just an absolutely thrilling subject, and I am so pumped to dive into this explainer with you today. We're going on an epic time-traveling journey to figure out how a crazy mix of incredible events, extreme climates, and just raw survival instincts literally forged the modern human. So let's jump right in, shall we?
Think about the Earth for a second. We know it's ancient, right? Roughly 4 billion years old. But us, Homo sapiens, we've only been around for the last 0.01% of that time. Let me put that into perspective. If Earth's entire history was a 24-hour clock, modern humans have basically only been here for the last ticking second. No way, right? It's incredibly humbling when you realize our whole history is just a tiny blink in the cosmic eye.
So, naturally, that brings up a massive question. Why on Earth did it take millions of years for our early ancestors to finally leave the safety of the trees, figure out how to stand upright on 2 feet, and eventually become the dominant species on the planet? What were the invisible forces pushing us to evolve?
Well, to answer that, here's our roadmap for today. We'll quickly cover the scale of human time, first steps in early ancestors, climate change as an evolutionary engine, the out-of-Africa journey, a web, not a line, and finally, the future of Homo sapiens.
All right, we have to rewind the clock way, way back into the deep past. Section 1, First Steps and Early Ancestors. Let's look at exactly when these major shifts happened. Around 7 to 8 million years ago, our lineage split from our closest living relatives, the chimpanzees. Then, by about 6 million years ago, we start seeing the very first signs of bipedalism. That means walking on 2 legs. Jump forward to 3.2 million years ago, and we meet the famous Australopithecus skeleton, universally known as Lucy. And then, around 2.8 million years ago, the very first species of our own specific genus, Homo, finally emerges. Now, coming down from the forest canopy to survive on the ground meant our bodies had to change, and drastically. Every single change you see had a very specific survival purpose. First, we lost those large, sharp, ape-like canine teeth. Why? Because we relied less on biting for defense and more on using tools. We also developed an opposable big toe, which completely stabilized our feet for long, exhausting treks across the savanna. Our diet shifted away from tough forest plants, meaning we needed totally different dental features. And crucially, we saw the initial spark of increasing brain capacity, just to manage this complex, brand-new ground-level environment.
And the ultimate payoff of all those adaptations, a massive leap in brain power. With the arrival of Homo erectus, our cranial capacity literally doubled. We're talking 850 cubic centimeters. This huge evolutionary leap was fueled by a better diet, figuring out how to master fire to cook our food, and inventing complex stone tools. It was a total game changer. But what exactly forced our ancestors to innovate so rapidly? Let's get into Section 2, Climate Change as Evolutionary Engine. Think of our physical bodies as a canvas that was literally painted by the climate. It's fascinating. In freezing environments, early humans like Neanderthals evolved shorter, stockier builds to hoard body heat. That's a biological principle known as Bergmann's rule. Conversely, Allen's rule shows us that in scorching hot regions, humans evolved taller, leaner bodies to easily sweat and dissipate heat. Our skin adapted to based entirely on UV exposure. Darker skin protected against the harsh sun, while lighter skin evolved in gloomy climates to help synthesize vitamin D. Populations living up high in the mountains even evolved unique genetic traits to efficiently use lower levels of oxygen. Biology is just amazing, isn't it? So the really crucial takeaway here is this. The volatile weather of the Pleistocene epoch wasn't just some background scenery. It was the main catalyst. It literally forced those incredible behavioral leaps we talked about. Making better tools, controlling fire, building shelters, and developing complex social cooperation, all of it was driven by the urgent need to just survive the crazy shifts between freezing ice ages and brutal droughts. And when simply adapting to the weather wasn't enough, well, we really only had one option. We had to move. That brings us to Section 3, the out-of-Africa journey. For a really long time, there was this huge, heated debate in the scientific community about how we actually populated the globe. The older idea, called the multi-regional hypothesis, suggested that archaic humans evolved into modern Homo sapiens in parallel, all over the world at the exact same time. But today, thanks to incredible advances in genetic evidence, the scientifically accepted theory is the out-of-Africa hypothesis. This proves that we all share a single origin point before kicking off a massive global migration.
And that brings us to the mind-blowing concept of mitochondrial Eve. Through modern DNA analysis, scientists were actually able to trace mitochondrial DNA, which is a specific type of DNA passed down only from mothers. They traced it from every single human alive today back to one specific female ancestor who lived in East Africa. Finding her completely revolutionized our understanding of our shared, unified origins. The timeline of this whole journey is just incredible. Homo sapiens first emerged in Africa around 300,000 years ago. But around 60 to 70,000 years ago, things got really tough. Prolonged droughts and a rapidly shrinking food supply basically forced mass migrations. Leaving Africa wasn't just some casual stroll to see what was out there. It was a desperate, direct survival response to climate instability, and it pushed us out into the completely unknown and incredibly harsh terrains of Eurasia. Now, this actually brings us to a huge misconception. Section 4, a web, not a line. You know that classic image of evolution? A straight line going from a primitive ape marching directly towards a modern human? Yeah, scratch that. It wasn't a straight line at all. As Homo sapiens migrated out of Africa and spread across the globe, they definitely weren't alone. They actually encountered other archaic human species who had left Africa hundreds of thousands of years earlier. We're talking about species like the Neanderthals in Europe and the Denisovans in Asia. And we know for an absolute fact that when they met up, they interbred. The craziest part? The evidence of this tangled web is literally inside us right now. Genetic analysis reveals that up to 6% of the genomes in present-day non-African populations actually come straight from these archaic cousins. And this genetic mixing wasn't just some random footnote. It provided a massive evolutionary advantage. It passed down crucial inherited traits that gave migrating Homo sapiens much better immune responses to local diseases, and even improved their resistance to extreme cold. Okay, so we survived the ice ages and the droughts of the deep past, but how will the rapid, intense climate change of our modern world affect our ongoing evolution? Let's look at Section 5, the future of Homo sapiens. To truly understand our future, we have to talk about something called epigenetics. Basically, this is the science of how our environment can actually turn certain genes on or off without changing our underlying base DNA sequence. It is wild stuff. It shows us how our biology might rapidly react to things like modern pollution, extreme heat waves, and even our highly processed diets across just a few generations. Essentially, it's adapting us in real time. Because make no mistake, we're under active evolutionary pressure right this very second. Disease patterns are completely shifting as warming climates expand the reach of mosquitoes carrying things like malaria. Our bodies are enduring unprecedented thermoregulatory stress from baking urban heat islands. We're physically adapting to radically different, sometimes scarce food sources. And the rising unpredictability of our modern environment? It might even be triggering cognitive and behavioral shifts that favor resilience and social cooperation. But there is one massive, fundamental difference between us and our early ancestors. Today, technological adaptation and biological adaptation are completely interwoven. Think about it. Wearable tech, air conditioning, modern medicine, engineered environments, they are all actively shielding us from extreme weather. We are quite literally using human innovation to rewrite the traditional rules of natural selection. So I'll leave you with this final, somewhat provocative thought. As we look forward to the decades and centuries ahead, will genetic engineering, artificial intelligence, and our everyday technology eventually replace natural selection entirely? Have we finally taken the steering wheel of our own evolution? It's a truly fascinating question about what humanity's next big leap will look like, and how our innovations today are actively shaping the very biology of tomorrow. Thank you so much for joining me on this explainer, and remember, always keep exploring.